Now we're going to shift gears quickly into hydrocarbons. A lot of the same things hold true as far as when we actually have an oil spill. It impacts our soils and plants and nutrition and all of that. And as I mentioned before, our soils have millions and millions of bugs that are in it. But most of the time when we have an oil spill, a hydrocarbon spill, or even a produced water spill that has hydrocarbons, oils, gases, fuels mixed in with it, now you have something that is going to act as a preservative package to the natural microbes, because again, super concentrates of any contaminant will naturally put simple bacteria into dormancy. They go to sleep. There's way too much of it. Oh my God, I can't do anything. Go to sleep. Just like I do after a good dinner. So again, our product has multiple different technologies built into it to be a complete system. First of all, anybody that sells microbes or enzymes or even surfactants that doesn't actually admit that part of what you're trying to do is to get the natural general health of the soil to work in your favor is lying to you. Because there's more bugs per square foot of any soil than you're ever going to find and be able to buy and afford to put back into the ground. Yes, do I have bugs in the jug? Absolutely. Do I have the largest packages that are available in the commercial market? As far as I know, I do. But does that compare with what's naturally in the soil? I also want to fix the soil so that the soil's working for me as well. But what I'm putting in, what differs from what we do, is that they're natural bacteria that you're going to find in your soils around the world. There are certain strains of bacteria that naturally exist. So instead of trying to change and put something that's foreign in, I'm going to put healthier versions of what naturally exists, as well as put components to go ahead and start breaking down the hydrocarbons, like I said, turn apples into applesauce, and also have delivery mechanisms to be able to move those microbes around, because now I have an ability to have the moisture move around because I've changed that dynamic within the actual soil structure. We just completed this project not too long ago. Crude oil pipeline blew in the middle of wherever it was in Texas. Dumped a lot of barrels before they found it, wiped out a lot of the natural tree vegetation. Immediate response, they went in there, they dug the hole, they fixed the pipeline, got it isolated, did the mop up, and then it was our turn to come in. This is how it was when we started the project. Again, can't emphasize enough, and everybody knows it, first response, don't worry about me. Get it sopped up, get it stopped, get it contained, minimize it. When we came in, we had to go ahead and remove a few more trees because they obviously were toasted. Wasn't really a good ability for us to go ahead and leave them in place. It allowed us to go ahead and do a couple of different simple techniques. The first thing that we did is we went through, and this area was one of the rundown areas, the down gradient side. We just actually did an aggressive rototill. We dug the trees out and we just did an aggressive rototill, and we came back and we did a heavy drench with our treatment product and water. Just in front of this area was where the actual excavation was done. Went down, I think, 9 feet to where the pipeline was, so we excavated the material, threw it up there. They repaired the section of pipe that needed to be repaired. Unfortunately, we wanted to go ahead and treat it as they were layering it back in, but the repair crew beat us there. Got it fixed, put the material back in the hole. So I had a large area about the size of this room, 10 feet deep, while I couldn't drench it. So we basically brought a geoprobe in and punched holes on 10-foot centers, put screen piping into the ground, and did a gravity feed to where we just hooked it to a tank with our diluted product, and it just went and soaked into the actual perforated lines and worked its way down through the soil profile. Now, the reason why I was fine doing it that way there is I knew all the material was just excavated, I knew it was slightly homogenized, and I knew it was open, and I knew our product with a little higher dilution would move through that loose material, and it did. We did some spot checks, we came back in a couple of days later, we did this on a 10-foot diamond pattern. So we had 3 holes that were in a little diamond, all 10 feet apart. And we came back in and did some spot checks with geoprobe to make sure that in the center of those diamonds, the product was moving, and it did. So we knew we were getting good saturation. Normally our pattern for geoprobe injection or gravity feed is a little bit tighter, but again, it depends on the soil structure. This is what I'm most proud of. Again, we treated, reseeded. Most of the TPH, and that was the requirement that we were regulatorily following, the TPH ORR. Lowest was 14,650, 20,000. So it was an average of about 15,000 on the milligrams per kilogram, which is pretty standard for a blowout like this. 35 days. We basically got them all into single digits except for one site. And one of the sampling points was right at the beginning of the transition from where they excavated, had the heaviest impact of oil just out of the excavation hole. So it was slightly higher in its loading. But we were done in 35 days. The customer was ecstatic. We obviously planted it. That's what grew in 35 days. Or I'm sorry, when we came back in 42 days. But we got no further action in 45 days after this project. One of the fastest remediations I've ever done. So how did we do it? Well, one, fast. You get on oil, any hydrocarbon, when it happens, it's easily degradable. Breaks down fast, is consumed fast. All you have to do is make sure you have the proper loading of the remediation product in there. Second thing is, this is in a nice covered hollow. Stayed very, very moist. We have perfect remedial conditions. If this was sitting out in the middle of our good state of Oklahoma that gets a little dry and a little windy, it wouldn't have gone this fast. Reason being is the moisture content that was constantly in there, it helped move the product all through the profile. We had a nice moist environment, and if you know anything about molds or bacteria, it loves to be moist, warm, and wet.
Did you get any rains during that 42-day period?
Sure did.
Okay.
I mean, Texas this spring, when did they not have rain? We were getting it. I don't think this ever formally dried out for 90, 120 days. I don't think it was ever a perfectly dry site from when we started working it to where we finished and got the hell out of there. Now, that was very advantageous. And obviously I like it because the results were staggering and perfect. But it's also one of those examples that demonstrates if you get on fast, your consumption is going to be fast, your reaction and results are going to be more effective, and also the cost to do this is more effective. It doesn't mean that when you're in an arid state, because again, even if we didn't get the rain and the moisture in the way that it's supposed to, your soil's still 4 to 6 inches down underneath. Usually maintain a certain amount of moisture and a certain amount of humidity in them, unless you go through a very extensive dry period or are in the desert or in very arid states. And in those situations, we've gone in, and if the remediation has to be done quickly, we've actually set up temporary irrigation systems to give it periodic moisture. That might be something that we have to do on the plan if there's a timetable that's done behind it. So it's knowing what the level of contamination that we need to get rid of. If it's simple benzenes. This project was one of our refinery partners. They now are doing things on an internal immediate response. The primary product that we use for hydrocarbon cleanup is called Soil RX. Soil RX has been reviewed by the EPA and is a Schedule 40 contingency plan certified product. What does that mean? Refineries can use it without asking anybody. Any federal cleanup, our product is certified to be used. You don't have to ask anybody to use it. Most states approve it because it's on that list. However, we still run through all regulators to get our product approved because it is organic, natural, and safe. But generally, the scrutiny that we've gone under, and the EPA has just re-scrutinized all of their products on the list. When we did it back when Deepwater Horizon hit, we were already in being approved. We did the additional safety testing, LD50 testing, water safety testing. Our product passed with flying colors that we can apply it to shorelines. The Coast Guard has approved it to be applied to water if we need to. It can be applied to land. It can be applied anywhere without any safety issues. That's what's important from the standpoint of our product. And there's, like I said, we export this around the world. I'm in 9 different countries with it. No country's limited our access. It's safe, it's natural, but we are moving bugs as well. This particular project, they get natural spills of gasolines and oils at their depots, their transfer stations within. So they started thinking to themselves, because they heard me talk one day, if you do it fast, it doesn't become a problem. So have a little work truck with a 50-gallon tank that you can go out and hit these parking lot beds or these fill valve areas and do it on a regular basis so it doesn't build up and you have to excavate or have a big problem. Crude oil, 30 days. All your basic BTECs knocked out except for the total xylene. And I think we went in there 45 days later in the xylene. Why? This was, it wasn't sweet crude, it was heavy crude. And that's probably why the xylene took a little bit longer. Sweet crude we consume real fast. Crappy crude takes a little bit longer. Gasoline spill happened basically on the same day. Again, same time frame, less than a month, it's completely gone. Again, it's consumed, it turns into H2O, CO2, and trace minerals. Hydrocarbons go away. Gasoline, diesel, fuel oils, crude oils, motor oils, unless it's synthetic. All of these things can be easily cleaned up. The faster you hit the stain, faster you hit the mark, faster you go ahead and manage it, the faster it goes away. Just like sodium and chlorides, the longer they sit in the soil, the harder it is to get rid of it. Crude oil's even more difficult because it will absorb itself into soil particles. So a lot of times when I'll get testing data as far as the levels of contaminant, I did a project for Devon Energy in Canada where they had a 15-year-old stockpile of material. The levels came out, and it was one of my first projects 7-8 years ago. I was feeling really good about our product. I was ready to go. Got the data, the levels weren't really that bad. Said, man, we can get rid of this. I'm gonna get in with Devon, they're gonna love me. We went and treated it, tested it. 18 days later, I tripled the number of hydrocarbons that were in the pile. They freaked. I freaked. I was like, holy crap. They were like, what'd you do? Just treat our pile with hydrocarbons? What are you doing to me? Because our product is black in nature. So I called my scientist and I'm like, dude, what the heck just happened to me? He goes, call him and ask him how old the material is. Why? He goes, ask him. Got them on the phone. It's 15-year-old material. He goes, normal testing methods on old aged materials do not soak the material long enough to extract the contaminant. So you got a false level. What was being read is what's available to the environment but what's totally in there was absorbed in. So the first thing that you did was go in and rip all of those hydrocarbons that were absorbed in there, you desorbed them for consumption, which is a good thing. So that you don't get constant breakdown over a period of time and look like you have a lag on your remediation. So now the first question on the questionnaire that we generally give people is, how old is this? Because if it's anything over a couple of years old, there's a high probability that the data that you're doing is slightly skewed. And either don't take any testing data in the first 30 days, and if you do, there's a probability that the number may be higher than what it originally was, because there's more there. So we're looking at, finding out these issues so that you guys don't have them. I've mentioned this a couple of times. It's all about expectations. My job is to develop a plan, work with our distributors and contractors and clients to develop programs that are going to work, but more importantly, build expectations according to how much money you're going to spend. If you don't want it to happen in 30 days, or you don't need it to happen in 30 days, you can use a little less product. It will still get the job done because bugs will keep eating. And there's other ways that we can buffer the environment if it's heavy to go ahead and make it work. But the loading wasn't excessively high on this. Take a site like this. It's one of my customers down in Argentina. It's an 11-acre land farm for Petrobras. Everybody told them all you needed to do was to take all of these spills and everything, dig them up, haul them to this field, and spread them out, and Mother Nature will take care of it all herself. It'll volatilize the natural bugs in there. All you gotta do is plow it every once in a while. You're fine. And just keep it, don't go higher than 3 feet. So that's what they did. 11 acres. From their exploration sites, from waste areas, all of that, they just covered it. Unfortunately, 14 years later, it had hardly moved. They didn't do anything to it because everybody said, nope, you don't have to put fertilizers on it. You don't have to do this. You don't have to do that. This area where you see, we just went out in the middle of the area and sprayed a section. And immediately, within 2 weeks, all of these weeds started growing and developing, and they're like, what the heck's going on? We haven't been able to get anything to grow on this site. Even though you can see they turn it on a regular basis, there isn't any residual plant life in there. But within a couple of weeks, we popped it up, we resampled it, moved it. Now, because this was 14 years old, the same situation occurred. Our original data was relatively low, and we thought it was going to be pretty easy to do. So we went in there and we did some deep cultivation. We went and treated it, retested it. Sure enough, the numbers spiked up and everybody freaked out, but stuff started growing. So they felt good. They were like, oh, the numbers are really bad, but oh, okay. Well, at least our neighbors aren't going to start wondering what's going on. So it took us a year and 3 different applications. Because we went in, originally we just did some shallow tilling to make sure we had the application right. Then they went in with rippers. And finally they came in with I think a D11 with some big rippers and got it down all the way through the 3-4 feet and got this turned up and turned over. And we worked the soil a little bit. Now it's good agricultural land and everything worked fine. Biopiling, we work with a lot of different facilities. If you have a large site and your depth of your contamination is a little bit deeper, bioremediation can work in a lot of different depths. It normally will start slowing down at 3 to 4 feet because we do need air and we do need oxygen. So it depends on your soil structure and soil makeup. But generally, when you have contamination of that depth, usually excavation is an option. or dig and haul is an option. So if excavation is an option, we recommend being able to excavate the material up and out, just like you would on a dig and haul, but keep the material on site. We go ahead and treat the area and we start layering it back down and in. So every layer that you're putting back in, 6 to 8 inch lifts, you're treating and saturating with both the moisture and the treatment product. You kind of homogenize the soil as you bring it out. You also find out if you have hot spots. Because I remember one of the first hydrocarbon projects we did together, we had all of our data and we were going to do an excavate, treat, and replace. And when we were excavating, we found a large area right in the center that had big tar globs in it. That this was supposed to have just been a produced water drilling mud dump site. Wasn't supposed to have any of this stuff in it. And if we wouldn't have excavated, we wouldn't have known it was there. We were able to manage it, homogenize it, get it remediated. But again, we don't have laser vision eyes to be able to really see down and through profiles. So data and information about the site is really important. This particular site on the biopile, they were just looking to be able to do it faster. So again, relative loading levels, pretty fast as far as on our VTEX ranges and on our larger fragments. One of the things that you'll normally see is that if we're going through what I like to call the ABCs of hydrocarbon analysis, a lot of times what's going to happen is our larger fraction ranges are going to drop first, and we may actually elevate our lower fraction ranges. And the reason being is, if in fact what I'm telling you is true, which it is, that we have materials in there that break down hydrocarbon chains into smaller pieces and bits, it goes to show if you have a larger, longer chain hydrocarbon and we're actually starting to fragment it and break it down, it's actually going to start showing as a smaller size hydrocarbon until it goes away. So we're going to fractionalize it, so it's not unusual for us to start with 47 here, and the next sampling, this may actually stay at this number or slightly elevate, and this one goes up because we're moving them down the line as we're starting to degrade and consume it. Again, expectation of working with the regulators, trying to figure out what testing methodologies they need you to use, and then we'll translate what your expectations of when we want to do our sampling times, because if we do it too soon, you may see things that are going to freak you out, and we don't want you to freak out. Or we're going to do other testing so that we understand what it is in conjunction with it, but we always have to follow what the CAP plan tells us, because we always do what the CAP plan tells us. So quickly, application techniques. I don't think there's a technique that I haven't had the pleasure of doing. This actually is George's Feet, the one project that we were talking about where we excavated. This whole wall was just covered with this black tar material that we weren't expecting. And we did 2 of these. This was the second one. So this was a dig it, lay it back in, treat it, and saturate it as we go layering up. I work with a couple of different companies, equipment companies, with very specific material processors. That if we excavate it, we run it through, it homogenizes the material and treats it and coats it. I have 2 of these running down in South Africa right now. We do a lot of business with Total, a lot of service station and industrial sites. Dig, treat, and replace, good old geoprobes, land farming, soil mixing. For gravity feed, if somebody didn't get my just before, this is a smaller gravity feed site where we brought the geoprobes in and they direct pushed 2-inch hole in and then inserted a 1-inch poly sleeve down into the holes. And then the top of it came out and we just plumbed it in to our feed tanks with the diluted product. We cracked the valve and just let it saturate the area. In this one, there's This one, the soils were really good. This was up in Maine. We did that for the Air Force Base. Those holes on the backside were offset, and then there was a third or fourth row behind it. And we just opened the valves, cracked them, just so that was trickling down. We left, we came back the next morning. The tanks were empty. We put a little bit of flush water down and through, came back, and that was just Jet A and some fuel oils that were at an old tank farm that had a ruptured line. This is actually me in Australia. 145 degrees when I was standing on that black liner. That was a, had hydrocarbons in it that we were taking care of. So our experience is pretty vast as far as helping everybody go ahead and figure out different ways of doing things. I'm going to spend just a minute on this, not a lot of time, but everybody says, ooh, how much does this stuff cost? You can use this cost factoring for both sodium and chloride remediation as well as hydrocarbon. It may vary slightly depending on your cost structure, but dig and haul today is usually, depending on the area of the country, and that number has gotten bad, to be anywhere from 55 to 200 per cubic yard. I know a couple of areas are up as high as 300 a cube now because of the disposal sites and where they can get rid of the material is a lot further away. The other thing that's more important today that you want to check with your legal departments, most disposal sites like Republic and Waste Management are now going ahead and having their companies sign on to their liability for the material that they had just accepted and charged you to accept. So dig and haul is no longer you pay and your problem is gone. You just paid a lot to make it go away, and oh, by the way, now you're stuck with everybody else's crap. And if there's a problem, you're on the name list and you now become a nice little thing for your attorneys to go ahead and take care of. That's very important that you guys now on the dig and haul alternatives are no longer, and if it is produced water and you're digging and hauling produced water spills, since it doesn't kill anybody, you're getting looped into all the other crap wherever that disposal site's taking. So your liability, just because it's just salt water, doesn't change. You're still on the liability hook. So really look into that, and that makes that cost a lot more important. So your cost can be anywhere from $15.50 to $35 a cubic yard. It can be more if you need it done faster, if the levels are higher, but that's a pretty good rule of thumb. And that does include some contractor costs as well as the cost of the product. In our experience, those numbers are up and down right now. Some areas, contractors are getting pretty aggressive with their pricing because they're just now getting their crews back to work, because there's work to be had. Whether we have to excavate, what kind of company we're dealing with, but that's not a bad rule of thumb. And again, age of spill, how quickly you want it done. My adage is, speed is expensive. I'm happy to do it, but if you need it done in a shorter period of time, it just gets a little bit more expensive because we have to put more product in there to work faster. It can be done. It's just more expensive. But that's the choice that you have.